Hello and welcome. In the previous video of this series, I introduced the idea of variables and their types. The link to the video is given in the description box. However, variables can also be viewed with the lens of the level at which they are measured, because some variables can be measured at different levels. For example, you can choose to measure age as a categorical variable, for example, child, teenager, young, middle aged, and old. Or you can measure age more precisely as 3 years, 14 years, 26 years, 40 years, and 70 years. So, variables can be measured at different levels of precision. Uh, Although not all variables can be measured at all levels, but some variables can be measured at more than one level. So, let's see what levels of measurement are. There are four levels of measurement, namely nominal, ordinal, interval, and ratio. Let's start with nominal level of measurement. So the nominal level of measurement is the most basic level of measurement, and this is just labels or categories, and in which there is no inherent order. For example, gender is reported as male and female. These are just labels. There is no order. You cannot say that male or female is bigger or better than the other. Similarly, color of a chair can either be green, red, or black. Again, green, red, and black are just labels. There is no order in them. You cannot say that black is better than red, or red is better than green, or green is greater or smaller than red, or red is smaller or greater than black. This is the nominal level of measurement. The next level of measurement is ordinal, which is which represents in which you represent variable as different categories. However, there is an inherent order in these categories, but the difference between categories is not consistent. Examples include income level. So, income level can be low, middle, or high. Condition of something or some person can be bad, good, or excellent. So you see, you know, excellent is better than good, good is better than bad. Similarly, high is greater than middle, and middle is greater than low. In the or low is less than middle, and middle is less than high. So these are labels, plus there is an inherent order in these labels. You can tell which is greater or smaller or better or worse, but the difference between categories is not much meaningful in the sense that it is not consistent. For example, you cannot say there is the same difference between low and middle as there is between middle and high. You cannot say that the difference between bad and good is same as good and excellent, because this is very subjective. However, the next level, which is level of measurement, which is called interval level of measurement, in addition to having an inherent order, there is a consistent difference between categories. But zero does not represent the absence of something at this level of measurement. We'll explain that how. See, for example, temperature. Temperature can be 98 degrees of Celsius, 99 degrees, or 100 degrees. So you see there is a difference. You can tell that 99 is greater than 98, and but 99 is smaller than 100. Similarly, you can tell that IQ score of 120 is less than 121 and 121 is less than 131. However, unlike the previous scale, ordinal scale, in which the difference between categories is not consistent, here the difference is consistent. There is the same difference between 98 and 99 as there is between 99 and 100. So you can precisely tell how much difference is there between 98 and 100, 98 and 99, 99 and 96 maybe, or 105. You can calculate this difference, and the difference is consistent in the sense that there is the same difference between 119 as 119 and 120 as there is between 120 and 121. However, at this level of measurement, 0 does not represent the absence of something. This is a bit tricky to understand. Let's take the example of temperature. Temperature can be 0, but 0 does not mean there is no temperature, because 0 temperature is also a temperature. Similarly, if you administer an IQ test to someone who is illiterate, and you will get a score of 0, but you cannot say that person he is completely unintelligent, in the sense that he or she has no intelligence at all. So at this level of measurement, 0 does not represent the absence of something, it is just a number. Then comes the ratio level. In ratio level, like previous level, there is an inherent order. The difference is consistent as in case of interval, as interval level. In addition, the 0 at ratio level represents non-existence of something. Examples include number of siblings, for example, 0, 1, and 2. So you see there is an order. You can tell 1 is greater than 0 and 2 is greater than 1. And the difference is consistent. And absence, the value of 0 represents that the quantity or that variable is 0, in the sense that it has no existence. 0 siblings means there are no siblings at all. Similarly, mass 0 kg, 2 kg, 10.5 kgs. So 0 means there is no mass. For example, you say you have 0 kgs of something, say rice, it means there are no rice, because the 0 represents absence of something. So these are the 4 levels of measurement: nominal, in which at which level there is no inherent order. At ordinal level, you have an order, but the difference is not consistent. At interval level, the difference is consistent, but 0 does not represent the absence of something. And at ratio level, ratio is same as interval, with the exception that 0 represents absence of something. In our example, which we have been discussing in this series, age, previous degrees marks, entry test marks, and number of siblings are the examples of ratio level. But name and gender are the examples of nominal level, because there is no inherent order in them. City is the city is also an example of nominal level, uh, and income level is at ordinal level, in which there is an order, but that the difference between categories is not consistent. And IQ score is an example of interval level of measurement. The question, however, is why care? That why care? What variable has been measured at what level? We need to care about this because the level of measurement is going to affect the kind of statistical analysis we can perform and the conclusions we can draw from our data. So this is going to be very crucial as we move to actual analysis phase. So thank you for watching the video. Keep watching.